Hi everyone, today I'm just going to show you an example of axisymmetric analysis. So here's an example of a tank, like a pressure tank, and the actual tank would look something like this. But by use of symmetry I can just model it as 90 degrees. So the way I've done that quickly is I've drawn up our sketch in the XY plane. Important to do it in that plane for the 2D analysis later, and then I've rotated that around 90 degrees. If this is not constrained in differently in the other planes, then we can just analyze 90 degrees of it and the rest will be the same. So that's what I've done. Alright, as a solid mesh we can analyze this. Say we find some aluminium, say this 6000 series, which is a higher strength. Let's use that for realism. Apply that to the model. Let's put some constraints in there. Alright, so for the in XYZ I'm going to just constrain this bottom point so it doesn't move, and then in X and Z, so we'll free the Y, I'll constrain this top point, or maybe even that edge. So that will move, that will slide up and down, free in the Y. Okay, so we've stopped any rigid body motion, so that this will solve. For force, why don't we apply some pressure internally? Let's find kilopascals. Yep. And let's say it's let's say it's 30 kilopascals, and we'll apply that to these inner surfaces in here. Preview. Yep. Alright, we've got our load, we've got our constraints, and we might just double check what the mesh looks like. It's a very large mesh. We can refine it, but that will do for now. Okay, that's all we need. Let's do a quick analysis. Okay, this will be our tank in 3D. Some problem there. Oops. Now we forgot our symmetry. So displace. So we can select our planes. Select that surface as a mirror. and that one is a mirror. Alright, let's try that again. There we go. Let's check out the result. Some deformation, and there we go. You can see that's moving freely in the Y. That point is constrained but not causing stress there. And you can see this is expanded out due to pressure. Alright, so that's what we would expect to happen. And here we've got very low stresses because the pressure was too low. But that'll do for now. So the high stress was 0.3 MPa. That's fine. It's all a matter of scale. Alright, quickly we'll go back and do this as a 2D. Alright, we go back into simulate. Let's remove some of these things. Let's go back into the revolve. Let's just move that back to say 10 degrees. Alright, so in the model setup we can change this to axisymmetric. Coordinate system is down here. The surface has to be on this XY plane, which is this one. Now we go back in here. Same thing. I've had these constraints, and it's free in the Y. And then the pressure. I think it was 30 we used. We used that edge. Material. Apply that to this surface. Alright. Yeah, we'll do this as our 2D. Quickly run that. Completed in half a second. And we go to the same values. Check if we've got the same thing going on. So there we go. It's less impressive because it's just a 2D, but it's just as true as the other one. Alright, so that's an example of axisymmetric